this video, we're looking at our first real programming exercise. We are going to look at the NESARC data that was in the Passion-Driven Statistics video. We are going to replicate that program on Kaggle. And then in the next lesson, what you're going to do is take the skills you learned from this one and apply it to the Add Health data set and the variables that you've chosen for your particular project. So first of all, where do we find our resources? If you go to Passion-Driven Statistics Project in our Schoology file, and you click down to Chapter 4, Working with Data, notice there's the NESARC sample code PDF. I put the PDF there. I also have the handout that's on paper because I know it's hard on an iPad to toggle back and forth between Schoology and Kaggle. And this just has the sample of all the code that you're going to type out so you can replicate the programming example that's done on the video. So either open this up on your screen as a PDF, grab the PDF from my handout pile, and let's go to Kaggle. So first, sign in to Kaggle. And I am first going to sign in my student account. I have a dummy student account to see what you see. And notice when you sign in, search for my account, and it's the one with pictures, with the picture of me that says DePaul Prep. And when you get there, notice I have 2 data sets for you, but go to Code. And before you saw 3 worksheets, or 1 worksheet, now you see 3. One was the creating a frequency table that we did before. Now you see 2 other worksheets. One is the student project template. That's your project that we will start next time. That's where you're going to put all the programming for your specific project. Today we're working on the student NESARC example. So if you click on that, it's the beginning of the program. So it opens up our libraries, NumPy and Pandas, that we're going to use. And what you need to do is click on Make a Copy, Copy and Edit. And now you're ready to go. So notice there's nothing there like before. There is nothing there. You are going to be making this program. I have just started it out by giving you the libraries that you need. Now, when you're typing a program, anytime you want to type code, you click on the code button, and that's where you put your programming code. Anytime you want to type a note, like a note to yourself, you can see I already typed one. You can type a note here. Hi, in this section, I am finding the frequency counts for each variable, or whatever you're doing in that block of code. You do that in a box, the markdown box. Then you click code and you type the code that you want to run. So those are the 2 different types of boxes you have. Markdown is just notes to yourself, notes to the reader. Code is where you actually type the code that you want programmed. All right, now give me a second. I have to get to my teacher account. All right, here's my example, and this is how we're going to do this. I'm going to show you on video what the code is and what the code does, and we're going to do it in parts. After I show you one part, you're going to pause this video. You're going to enter that code on your program. Make sure it runs. Make sure you get the same output I get. Then when you do, you're going to turn this video back on, and you're going to go through the next part. So part 1, We already have the beginning of our program. We're importing the libraries that we need to run our program. And now we're going to import the file that we need, the Kaggle file. So remember from before, whenever we import a data file, we have to name it. So we're going to name it data because they named it data in the video. For your personal project, you can name it whatever you want. So we have data and then we have equals. What is our data? Well, we're reading in the data file, the NESARC data file that I put on Kaggle for you. So it equals PD. Well, what is that PD? That PD is pandas. And the command to read in data is from the pandas library. So we have to tell our program what library to go to. I'm going to pandas. I'm telling pandas to read in the CSV file. The CSV file, it's like an Excel file, only the data is all squished together really tight with commas in between it. So we do the command read _ CSV. We tell it what file to read in. That's /Kaggle /input /NESARC /NESARC _data.csv. And the low memory equals false is just what was described on the Passion-Driven Statistics videos. It helps reduce some errors that we could get reading in our data. Now, whenever you open and run your code, you have to run it from the beginning first. Otherwise, these libraries won't be entered and you'll get an error. But you don't have to run all the code every time you run code. As long as we run this top code once, then we can just run the individual code by clicking on the triangle to the left of that specific cell. Now, we've read in our data, or we will as soon as we see that this command has finished. But we won't see anything because we haven't told our computer to print anything to us. So after we read in the data, we're going to take a peek at it. We're going to see the size of our data. And to do that, try printing in. And if your code is still running like mine, it's okay. You can get the next cell ready to go. Try to run the code or try to print the code. Print length data. Sorry, I accidentally hit that code box. It's okay if we skip it. Oh, there we go. I've read in my data. It's done reading in. So now we want to print length of my data. We want to print the length of the columns in my data. We want to find the data shape. And we want to find any information about my data. So if you print in those commands and then hit run, oh, I'm having trouble with data shape. There we go. You should get output that looks like this. The length of my data is 43,093. So 43,093 people have responded, and we have their data in this file. I think you can see now why an Excel file would just be, it wouldn't be easy to use, and this is why we use programming, because our data is so large. How many columns? 3,008 columns of data. In each column is a question. What's your first name? What's your last name? What's your age? How many times have you smoked in the last month? Each column is a piece of data. The data info gives me the same sort of information in a different format. It also tells me the data types. D type is data type. A float 64 is a floating point integer, a floating point decimal. It's just a number with a decimal. Integer 64 is simply an integer, and an object includes words and numbers. So green, yellow, blue, orange, yes, no, those sort of things are objects. So pause the video, make sure you can type in these commands, make sure you get this output, and then come back to this video. Next, we're looking at our variables. And we want to determine their data types. And then once we determine their data types, we have to determine whether we need to change them to numeric or not. The 5 data types that are used in the program on the video are these 5 typed right there. And what I want to do is look at each data type and see what type it is. So if I try, let's do the first variable right here, ETHRACE2A. And if I put data, my variable name, .data type, it tells me what my data type is. That one's an integer. I don't have to change that. It's already in numeric. Let's look at the next one, TAB12MDX. What type of variable is that? That's an integer. That one's great. It's already a number. Let's leave it. Let's look at check 321. That data type is an object, which is not a number, so that one we want to change. Let's try the data type. I can type it right under. It's just a little more typing. Data S3AQ3B1. And we'll run it. And when you put these 2 commands together, only the second one will print. That one is an object. Let's do the next one. S3AQ3C1. And run it. That one is an object. Let's do the last one. Age, which I'm guessing was entered as a numeric because people tend to say how old they are with a number. Number of years, number of months. But let's just run it. And you'll see that age is an integer. So I'm 18, I'm 25, I'm 36, however old the person is. So the 3 variables that we have to change to numeric are the check 321 and the S3 variables. Now, how do we do that? The code that I have for you is a little bit different than the video, not much, but a little bit different. And use this code because this is the code that works with Kaggle. Remember, the program that they're using, the interface that they're using on the video is Spider. So some things are a little bit different. We use Kaggle because it's online and it works with your iPads, and it also has a ton of data sets on there we can use throughout the year. So when I want to change these variables to numeric, what I do is I make a new variable. And again, you can call the variable whatever you want. You could call it Fred, George, X, Y, Z. It doesn't matter. But in programming, you tend to want to make the variables descriptive, something that you can remember. So if you look back at them, you're not thinking, oh, I made a variable A. What does A mean? So what I did is renamed my variables with a num in front. So num check 321, num S3AQ3B1, and num S3AQ3C1 to indicate that's the numerical variable for the object variable. Easy for me to remember. What is the command? It's equal PD, so I'm telling Pandas to use the command to numeric, and that's the command that changes an object to a number. The only other thing we have to add in after our variable name are the words errors equal coerce. And that just prevents us from getting an error message if I were to have any data points that could not change to numeric. What it does is it takes those entries that cannot be changed to numeric for some reason, and it puts them in a separate category. And we will see that category later on when we go to chapter 5 and we are looking at our data more closely. So right now, just enter in errors equals coerce in quotes with your closed parentheses. And then I want you to run this code. And notice if you check your variable, your new variables, and their D types, you should get a float 64. that is a floating point integer, or it is a variable with a decimal. And I will check my other ones. I'll run my code again. And the S3AQ3B1 is now also a float. And let's check the last one, which is my S3AQ3C1, and make sure that that is also an integer. So we're good to go. My variables are now numeric. So I want you to pause the video, make sure you've typed in this code, you've checked each of your variables, you've typed in this code to change your object variables into numeric. Now the meat of our code, the frequency counts. That's what's all important to us. We want to know how many of those 43,000 people, how many exactly do we have? 43,093 people. We want to know how many of them claim nicotine dependence in the past 12 months, how many of them smoked in the last year, the frequency at which they smoked, and the quantity when they smoked. That's what we want to do in the sample study. So we're going to start with the first 4 lines of code. So the first 4 here. Once we get these 4 running, you can simply copy and paste them with minor changes for all the other variables. And I'll split them out here. And we're just going to do the first one for the variable tab12mdx. Now, we have to name 2 variables. In the video, they named them C1 and P1 for our first count and our percentages count. You can name them whatever you want, anything that makes sense to you. These are short names. They work well. What are we counting? We're counting the variable tab12mdx from my data set that we call data. What am I doing with that variable? I'm counting it. So I use the command .value_counts. We use sort false because we don't want to sort our data at this point into any sort of other sorting. We're just going to take the data as it's sorted in our original data set. Now, our computers made that count, but now we have to tell our computer to give that count to us. And to do it, we use the print command. What are we printing? We're printing the counts, and I put it in quotes. Whenever we print something to ourselves, remember, we're not the only ones reading our program. We have an audience. You might have a boss. You might have coworkers. You might have people interested in your study. So you just can't have your code spitting out numbers. They have no idea what these numbers are. You have to tell them. And so we print something. We print a message. How do we do that? In Python, we just say print, and we put in quotes whatever we just directly want to say to our audience. So that wording is counts for tab12mdx. We define what that variable is because nobody reading our study is going to know but us. And we want to tell people that is the nicotine dependence in the past 12 months. A response of 1 is a yes. And usually in code, if 1 is a yes, sometimes 0 is a no, sometimes 2 is a no. You have to kind of look at your code to tell what the responses mean. That's why when I had you choose your variables, remember how I told you, take a picture of that code, we're going to use it. And you put that picture on your PDF. And you did that because this is where it's going to start coming in, where we need to use that when you write your own program. And then after we tell our computer to print that line, we tell it to print those actual counts. So we put the variable C1. Notice it's not in quotes because we don't want the program to print C1. We want it to give us the actual counts. I copy these first 2 lines and I paste them because it's going to be nearly the same thing, except the second time around, I want to convert those counts to percentages. So I use P1. Everything else is the same except how do I tell my program to print percentages instead of counts? I use the word normalize equals true. And that will change my variables to percentages rather than just a frequency count. Then I want to print, and instead of counts, I'm going to put in percentages for my variable. What's that variable mean? Nicotine dependence in the past 12 months, where a yes was 1. And then I have the computer print those percentages to me by putting in the variable P1. I'm telling it to print the value in P1. Hit run before you type in all the other code that I have underneath here. Run that, and you should get the first few lines right here. Counts for your variable, TAB12MDX, and percentages. Notice I've told my audience what this variable means, that a 1 indicates yes, because my data comes out as 0, 1. So if 1 is yes, 0 in this data set is a no. 38,131 people responded they were not nicotine dependent in the last 12 months. 4,962 people responded that they are nicotine dependent. That in percentage form is 88.4% said they are not nicotine dependent, and 11.5% said they were nicotine dependent in the past 12 months. Once you get these lines running, I want you to do the same thing for each of the other variables. So what you can do is just copy these 4 lines, paste them 3 other times, and make minimal changes. Each count has to have its own variable. So I have count 2, count 3, count 4. Each percent has to have its own variable. So I use P2, P3, P4 to keep it simple. We're going to change the variable name, and notice the other variables I am keeping count of were the check 321 and the S3AQ3B1. So we have to use the numerical version of that variable, not just the check 321. We're going to count them. We don't necessarily want to sort them, so we do sort equals false. And we're going to have to change the print statement. Now it's counts for the variable check 321. We have to tell our audience what that meant. It was the number of people that smoked in the past year. The S3AQ3B1 is the usual frequency when they smoke cigarettes. And the S3AQ3C1 is the quantity when they smoke cigarettes. Now, when I do the value counts for the frequency that they smoke and the quantity, note that I added the command sort index. And I did that because now it sorts by the answer. So did they respond the usual quantity when they smoke? 1, 2, 3. It sorts by the quantity. If I don't have sort index on there, I'm going to take it off. And I'm going to run this program again. I think I have to run my whole thing again here. If I don't put the sort index on there, what happens is it prints out your data by value. So the category or that has the most counts will print first, down to the least. And you'll see how that is after this runs here in a few minutes. The larger your data set, the more time it's going to take to read in, but once it reads in the data set, it goes pretty fast. Let's take out the sort index here. Let's see what it does. Oh, I'm looking at the wrong one. Okay, here we go. So see what happened to our data. Instead of 1, 2, 3, 4, 5, 6, and 9, now it's 1, 6, 4, 3, 2, 5, 9. So it ranks my data by the number of responses, greatest to least. If I don't want that to happen, I type in sort index, and I rerun that. And now it is sorting my data by the left column. And I can do the same thing for my larger data set. Maybe you can then see when it's useful, when it's not. When you have a large data sets with a lot of categories, you might want to know which category has the biggest count. Then you don't want to use sort index because now I have my biggest count up top. 5,366 people replied 20. And I believe that's number of cigarettes in a week for that data set. And then it goes down in decreasing value by their response. But say I want to sort it by the left column of data, that's when I use sort index. So you get to pick in your program, how do you want your data sorted and why? And if you want it sorted by the left column, there we go, use sort index. If you want it sorted by the right column, so the biggest categories on top, then you don't use sort index. So what I want you to do now is to stop the video, type out all this code, then make sure, come back to this video, make sure your output looks just like this output here. That means you did your program correctly. So look through this data, look at your output, look at this output. This is the same output that's on the video, so you can look at the video if you'd rather look at the video. Make sure it's the same. Then come back to this video and we're going to do the final part of the program. Okay, welcome back. So far, you have your program running great. We have our counts, we have our percentages. Now, this last section that was in the video for chapter 4 is how to narrow down your data. And there's a disclaimer in the video that says you may not use this. And that's true. For your program, your personal project for this year, you may not use this. But there might come a point where maybe you do. Maybe you do want to know about a subset of the people that you're studying. So here's an example of what if I want to look at a subset of data. So a subset of the people that responded to my survey, I only want to look at 18 to 25-year-olds. And I only want to study those who have smoked in the last 12 months. How do I narrow down my data set? And I do it with code that's similar to the following. First of all, I have to make a new data set that's a subset of my original data set. And in the video, she just called it sub 1, indicating subset 1. You can name it anything you want. Now, what is my subset? I have to use conditional statements to get that subset. So I'm taking a subset of my data, that's called data, and I want to include those that are aged 18 to 25. So the variable age has to be greater than or equal to 18, and the variable age has to be less than or equal to 25. So I do data age greater than or equal to 18 and data age less than or equal to 25. And that gives me the results of just 18 to 25-year-olds. But I want to go one step further, is I only want to include those who have smoked in the last 12 months. So I do and data, and the variable that asked them if they smoked in the last 12 months was check 321. And I put equals 1. So why do I use equals equals? I use equal when I'm assigning a value to a variable. When I'm doing a conditional state and I'm asking if data equals 1, if data falls in this category. Remember, 1 was the column or the answer. If they smoked in the last 12 months, that was coded as a 1. I want to see if this variable equals 1. You have to use the double equal sign or you'll get an error. Then I want to go ahead and I want to find the value counts for that variable. I want to sort it by the left column. I want to print a message to anybody using my code. This is the counts for age. And I print that count, that is C5, because now I'm on my 5th count in my program. P5 is that same count as a percentage, so I use the normalize equals true command. And I get the counts for age. So 161 18-year-olds, 200 19-year-olds, 221 20-year-olds smoked in the last month. Notice again, if I don't put the sort index on there, which is fine, you don't have to. If I run my program, then I get the age group that smoked the most, and that was 241 24-year-olds. 21-year-olds were the next age group that had the most smokers, 239. So you can use the sort index as it's useful for you. Next, I got the percentages. So here are the percentages. 9% were 18-year-olds, 11% were 19-year-olds, 12.9% were 20-year-olds. Out of all the people 18 to 25 that smoked, it breaks it down by percentages. The last commands might look like they're not needed. What we're doing is we're taking the value counts for those in check 321. And of course, we sorted our data before by check 321 equaling 1 or answering yes. So the response I get for this is 1,706 people fell into category 1. There is no category 0. There is no, because my subset of data only included people that answered yes. So you might think this is kind of a waste, but it gives you that total. It gives you the total of how many people we are having in the subset of data set. And then the percent just gives us our percent, which is 100% of my data. 100% of the people in the subset were people that answered yes to smoking within the last 12 months. And this command right here just gives us that amount, which should be 100% of our data, 100% of our subgroup. So it's kind of like a check. If this wasn't 100% and there was a different percent there, you would know something's messed up in your code and you would have to look further. Now, we have been through the program. I want you to now turn off this video. I want you to go try to enter in this code into your program. Make sure you get the same responses that I have right here or that they have in the chapter 4 video. At that point, once you're done with this, I want you to go ahead. I want you to go back to your notebooks. I want you to open your student project template. And this is where you are actually going to begin your own program for your own project. So you open the student project template and look what I have for you. I have very minimal instructions. So at first, I have the code set up so you can import your libraries. I have typed in what you need to type in to read in the Add Health data set. After that, I have typed in what you need, the print length commands that you have to put in so you can actually look at that data set, see how big that data set is, get info from that data set. And then here's your chapter 4 task. Notice it's blank because you're going to decide what you need. And you're going to do the same thing in here that we did for the smoking example. You're going to type in your two variable codes. You're going to look at their data type, so do D type. If they're an object, and it's going to be different from everybody in the class because you all pick different variables. If they're numeric, great, leave them alone. If they're not, if they're an object, you need to change your variables to numeric with the same commands that we used in the smoking example. Then you want to use value counts to make a frequency table. You can sort it as you like, so you can use sort index or not. Then you're going to change that frequency table to percentages using the normalize equals true command. And then again, sort your data if you would like or if you would not like. In addition, if you want to, you can use conditional statements to further narrow your data if you want. I am guessing at this point in the program, you're probably not going to do that and see how your data pans out for the next couple of chapters. Then if you want to narrow it down later there, you can. But you might want to play with your data now and do that. This is what we're going to do the next day. If you can get the smoking example done today, that's great. And then you'll be ready to step in this at our next class period.